Finding the right distance for a thickening operation to achieve a certain volume or weight can be a quite cumbersome process in alias. This is especially true if the thickening operation has no history, and when the undo-redo stack is destroyed when executing the mask tool to perform the volume measurement. Hi folks, I'm Gigi, and in this video I will show you that you can use Dynamo to automate the process of finding the right distance for a thickening operation to achieve a certain volume or weight. This is true for both the thickening of Nurbs topology as well as the thickening of subdivision bodies. So let's dive into it. Let's start with the subdivision thickening because I found that process especially painful. If you're using the regular thicken tool in the subdivision tab of the palette, then you will find that there is no create history option. So you're not keeping your original input geometry, which means that if you do pick nothing, pick object, you only have got one object. And while you can now still undo and redo, as soon as you call the mask tool to check, for example, for the area, the volume, from the volume you can also compute the weight, then you will find that after you've called the mask tool, the undo redo is no longer available because the mask tool doesn't support undo redo, and as soon as you use such a tool, the undo redo stack is destroyed. So what you now basically got to do is you got to create security copies of your original input subdivision body and then start from there until you find the right offset distance to hit a certain volume, for example. And obviously this is not what you want to do. So the first thing I did to overcome this is I wrote my own subdivision thicken tool, which looks basically like the normal thicken tool. You select the subdivision body, you put in a distance, and then here you have a keep originals option to keep the original geometry, and by that also have history. And as the regular tool, it provides you with the option to crease an edge. So pick nothing, pick object, and I can always come back here to query edit this one and change this one to a different distance. And what this now allows me to do is I can go to the mask tools, say like, hey, go for what's your current volume? Need a little bit more. Then I can go to query edit, increase this one, nothing, pick object, choose the thicken result and just recall the mask tool, get my change volume, and now I could iterate until I find the volume I want to have. But this is also more cumbersome than it should be, and this is why I wrote another script I'm going to show you now, where you give just a target volume and let Dynamo do the job of finding the right distance. So here's the subd thicken by volume Dynamo player script. The first thing you need to understand is that Dynamo works without any units. It takes the unit from the host applications, in this case alias. So in the construction options, I've set my main units to be centimeters, and therefore Dynamo will compute based on that unit, which means that here I'm asking for example for 2000 cubic centimeters. I want the thicken value to start with 1. I want the step size Dynamo shall tag to be 0.1 and should iterate a maximum number of 10 times to find me a thicken value from the starting value 1, which achieves this volume here with a tolerance of 100 cubic centimeters. So let's select our bottle and hit build. And then we can see that Dynamo suggests a thicken value of 1.6 to achieve a resulting volume of 2000. So if you now increase this, for example, to what about if we want to have 3000? And then you see that with a thicken value of 2, we get 2612. This is too far away from the 3000. And this is because our max iteration is currently stopping at 10. We are not allowing Dynamo enough iterations to get there. So if you now, for example, increase the amount of iterations to 20 and hit update. Then you can see that Dynamo suggests a thicken value of 2.2 to achieve a volume of nearly 3000 cubic centimeters. Obviously, the algorithm could be improved by letting Dynamo find its own iterations and better step size. It could determine itself, but that's not the point of this video. The point of this video is that Dynamo can do that. And if you need such a script, it could, of course, be optimized to run faster and find those values itself. The algorithm to do the same on Nurbs surface topology is pretty much the same. So this one just allows for a different geometry type to be selected, and here I've chosen a step size of 0.01 with 15 iterations to let Dynamo do the job. And in the end we get there and achieve nearly our wanted volume within the given tolerance. And again, Dynamo could take care of most of these parameters probably itself if you do a little bit more smart programming, but that's part of a different video or different user request. I hope you found this one useful and that you will invest into looking into finding more smart approaches to find the needed volumes and weights. If you have any questions, don't hesitate to contact me. Stay curious.